We're going to start with the same 7 layers of the OSI model. We're going to say that this is the source. And then we're going to have those same 7 layers of the OSI model for a destination. Let's say that there is a process on the source machine that needs to talk to an outside device. So the application message, or the application layer, prepares a message. And that message, to the best of its knowledge, is delivered directly to the application layer at the destination. It doesn't care what other sort of work that it has to go through. It takes the message and it presents it to the presentation layer. The presentation layer takes that message, wraps some header information on it, and then, to the best of its knowledge, is speaking directly to the presentation layer at the destination device. And the way that it does that is it wraps header information and it passes it down to the session layer. The session layer is responsible for establishing the session or the connection between the two devices. So it also adds some header information to the message and passes it down to the transport layer. So the session layer, to the best of its knowledge, is speaking directly to the session layer at the destination. Once it has added header information and passed it to the transport layer is responsible for the guaranteed delivery of the data, for any error control, error recovery and flow control. So it might split the single message across into many pieces and parts, because there's a very good chance that the single message is too large to pass as a whole. So it's going to break it up. It's going to take each one of the individual pieces and parts, and it's going to put header information on each one of them and pass each one of them down to the network layer. So as far as the transport layer is concerned, it is talking directly to the transport layer at the destination. Now the network layer is responsible for flow control. The network layer is responsible for routing. So the network layer needs to know the destination address, the IP address of the destination. The network layer also knows that there's a very good chance that it's going to, in order to get to the destination, that it's going to have to route it through multiple routers. And so I'm going to put a physical router here, and let's say that there is another router here. At each router, there's also a network layer. And what the network layer at the source is going to do is it knows the IP address of the destination, and it knows the next best router to send that to in order to send it along its destination. Once the information gets to the network layer at the router, this router knows that it hasn't reached its final destination, and it is going to route that information to the network layer at the next router. And the network layer at the next router is going to know that it has not reached its destination yet, so it's going to route the information based upon the IP address, let's say, to the final destination. So what the network layer does is it attaches header information to each one of the individual packets, and it's going to push them or pass them down to the data link layer at the source. Now the data link layer is responsible for the reliable transit of the data across the physical link. It's going to break down each one of the individual packets into even smaller pieces and parts, and it is concerned with the physical address of the router. So there is a data link layer on each one of the individual routers, and it has a MAC address. Each router has a MAC address. This is like the serial number that you find on the back of your refrigerator or on your new printer. The MAC address is a physical address of the device. Each one of the routers also has a MAC address. And so the data link layer it doesn't care about the final destination like the network layer does. The data link layer is only concerned with getting it from one place to the next, from the source to the first router, and then let's say from the first router to the second router. And then the data link layer at the second router is only concerned with getting it to the router that would be the destination computer, to the router that is connected to the destination computer. So it finds the MAC address of the next router or the next hop along the line, and it passes that information down to the physical layer. So the physical layer is the hardware that is taking it from the source to the first router. And when it gets to the first router, it's going to move up to the data link layer of the first router. The data link layer is going to look at the MAC address and say, you have arrived at your destination. And so it's going to pass that piece of information up to the network layer at the first router. The network layer is going to look at the packet and it's going to say, you have not reached your final destination. And so it's going to pass it down to the data link layer. And the data link layer is going to find the MAC address of the next router. And so then it will pass it across the physical layer, the ones and the zeros, bit by bit, to the next router. When it gets to the next router, it passes that information to the data link layer. And the data link layer says, you have arrived. So it passes that information up to the network layer. The network layer recognizes that it's still not at its destination, and so it's going to pass it back down to the data link layer. The data link layer is going to find the MAC address of the router that the destination computer is connected to, and it's going to pass it across some kind of a physical medium to the final destination. It passes up to the data link layer. The data link layer says that you have arrived. It passes that information, or each one of those packets, up to the network layer. The network layer, recognizing that we're at the destination IP address, says that you have arrived. It passes it up to the transport layer. Remember, as I said before, that based upon the source, the transport layer at the source thinks that it's communicating directly with the transport layer at the destination. When the message of each one of the individual packets arrives at the transport layer, at each one of these individual layers at the destination, it strips off the header information for that particular layer. It reads the information that's inside, and if we haven't reached our destination, or if we have, it's going to pass the information inside up to the next layer in the OSI model. That next layer is going to pull off the header information, make sure that there is no problems with the message, and pass it up to the presentation layer. The presentation layer is going to strip off the header information from each one of the individual packets. It's going to assemble the packets into a readable message, and when all of the packets have arrived, it's going to pass that message up to the application layer at the destination. Now, what I want you to notice is this is just one communication from a source to a destination. So the source has a message that it wants to send to the destination. It prepares that message and it passes it down through each one of the individual layers of the OSI model, and each layer adds its own header information onto it, breaks it up into multiple packets, and passes it down. It is passed bit by bit by bit across a physical layer, probably through several routers, until it finally reaches bit by bit the physical layer at the destination. It is passed up through the layers of the OSI model at the destination, and each one of the layers is stripping off that header information, kind of like unwrapping the layers of an onion, until it gets to the destination. This is just one message. Maybe the source is saying, I would like to launch HomeDepot.com in my web browser, and the destination is wherever HomeDepot.com is housed. And when HomeDepot.com gets that message that I would like to open the browser, it is going to respond to the message. Once again, it's going to push it down through the 7 layers of the OSI model, across the physical medium, along each one of the individual routers, until it gets to the destination. It's going to move up to the application layer, at each layer stripping off the header information that was put on it as the message was passed down the layers at the destination. And then we're going to present Home Depot's homepage. So let's say the next thing that I do is I type in search information because I want to know how much baseboards are going to cost, baseboards and trim. Once again, that message passes down the 7 layers at the source, across some kind of a physical medium to the destination, and up the 7 layers. The destination said, oh, you want to search for baseboards? Let me present the search results to you. And so that message is then passed back down through the 7 layers, across the physical medium to the destination, up the 7 layers, and I see them presented beautifully as the search results on my browser. So this is almost instantaneous. I can tell that it's almost instantaneous because if I do a search in my browser on HomeDepot.com and it takes more than a heartbeat to return the search results, I get all impatient and upset that it's taking too long. But in actuality, it is moving. Let's say, for instance, that this web server, that Home Depot's web server is in Seattle, Washington. And so the messages that are being passed between the source and the destination and back to the source and back to the destination are traveling across some physical medium from my house or from my office on the Davis campus all the way to Seattle, Washington and back. And the messages are being passed almost instantaneously. If there was any kind of a delay, I would be upset about it. And so I want you to take this into consideration the next time that you're seeing delays when you're trying to launch an app, or it's taking 12.5 seconds for iHeartRadio to launch on your cell phone. That this is the communication that is actually occurring between the two devices, and it is absolutely amazing the speed at which this can occur. So let me know if you have any questions.